Hi everyone, welcome to our class. Today, I am going to discuss translating mathematical statements to mathematical expressions using the mathematical symbols which we have already discussed in the previous video. In English language, noun refers to the name of person, place or thing, and are referred to as the subject of a sentence. In mathematical language, a noun is an expression and represents the object of interest. Further, in mathematics, an expression is a symbol or combination of symbols that represents a quantity or a relationship between quantities. A mathematical expression may be represented by a number or a letter representing a number known as variable in some functions or unknown in some equations. Examples: 20, -4, A, B, or any letter in the alphabet. So they are considered as a mathematical expression because they could represent a number. A mathematical expression can also be a combination of numbers, letter or letters representing number, and operation between the numbers. For example, 3x plus 1, -4xy squared, 3a plus b all over a, the square root of x squared plus xy squared, the quantity 4x squared plus 3z times the quantity 4x squared minus 3z. Each of these is considered as a mathematical expression. Let us now translate mathematical statements into mathematical expressions using symbols. The product of 5 and x. So when we say the product, that means multiplication. So the product of 5 and x means 5 times x. So you can put your x inside the parenthesis that denotes multiplication, or you can just write 5 and x side by side. Again, if you have a number written beside a literal number, that means multiplication. Other symbols used for multiplication is using the dot. Take note how we write the dot which denote multiplication. It is written at the center between 5 and x, or we can also make use of the symbol for multiplication. However, these two symbols that denotes multiplication are seldom used in writing mathematical, especially in handwritten mathematical expression, because you'll have a problem identifying x for multiplication or x as a variable. Okay, so we read this one as 5 times x or simply 5x. The statement the sum of -2 and a. When we say sum, this one denotes addition. So the sum of -2 and a means -2 plus a. The statement x increased by 3. So increased means addition. So we write first x, then we add in there 3. That's x increased by 3. The statement 3 added to x. So 3 added to x, that means you're going to write first x, then you add 3. X more 3. X more 3, so you write first x, and then you add 3. 3 more than x. So take note of this statement, 3 more than x. So when you have this statement, 3 more than x, you're going to write x first, then you add 3. So that would give us now x plus 3. All of these statements, x increased by 3, 3 added to x, x more 3, 3 more than x, are represented by the same mathematical symbols x plus 3. We have here the statement 3 more x. So take note of the difference between 3 more than x and 3 more x. So when we say 3 more x, we have 3, then you add x. So when you have 3 more than x, your 3 is added after x. 3 more x, you write first 3, then you add x. Okay? Okay, let us translate more mathematical statements. 3 times a number minus 2. If we're going to represent this number by a variable x, so we'll have 3 times x is 3x minus 2. Thrice a number decreased by 2. Thrice means 3 times. So again, thrice a number would mean 3x or 3 times x decreased by 2, it is minus 2. Thrice a number less 2. So thrice a number is 3x less 2. That means we subtract 2. 2 subtracted from 3 times a number. So that means we have to write first the 3 times a number, then we less 2. That would give us again 3x minus 2. 2 less than thrice a number. So take note again of the term less than. So 2 less than, that means we are going to write first this thrice a number and then we subtract 2. Okay, all these statements, 3 times a number minus 2, thrice a number decreased by 2, thrice a number less 2, 2 subtracted from 3 times a number, or 2 less than thrice a number, they actually are represented by the same mathematical symbol, 3x minus 2. Okay, so let us translate more mathematical statements. The statement the product of 12x and cube of y, product means multiplication. So that will be represented by 12 times x and the cube of y, or we can write it as 12x y cube. 12 times x times y cube is represented by the same symbol, and we read this as 12x y cube. The statement cube of twice the number. So cube means to raise something to the exponent 3. So what is that quantity? It's the twice of the number which we are going to raise to the exponent 3. So this will be represented by the quantity 2x raised to 3. Or we read this one as the cube of 2x. Twice the number raised to 3 is represented by the same symbol. The quantity 2x raised to 3 are all represented by the same symbol, the cube of 2x. The statement sum of squares of x and y. Sum means addition. What are we going to add? The squares of x and y. That means you're going to get first the square of x and the square of y, then you add. This is the sum of the square of x and the square of y. Or we read this one as x squared plus y squared. Square of sum of two numbers. If let that number be represented by x and y, then we say square means raising the quantity into an exponent 2. So what are we going to raise to 2? The sum of the x and y, of these two numbers x and y. So that means you get first the sum of x and y before you raise the quantity to 2. Or we read this one as the quantity x plus y raised to 2, or you can read it the same as the square of the sum of x and y. Okay? A mathematical sentence is a statement which compares two mathematical expressions. The statement, however, must be determined either it is true or false. Example, 20 is 3 greater than 17. So in this statement, is the verb of the sentence, and in mathematical symbol, it is represented by equal sign. So we have 20 is 3 greater than. So recall in our previous examples how we translate this one to mathematical symbol. So 3 greater than 17, that means you have to write first 17 and then you add 3. So this is now 20 is equal to 17 plus 3. Of course, knowing that 17 plus 3 is 20, then we say the statement is true. The statement 9 is the product of 7 and 2. So again, we have in here 9 is represented by the equal sign. The product of 7 and 2. Product means multiplication. So 7 times 2. Which is obviously in here, the statement 9 is equal to 7 times 2 is a false statement. Okay? 3 more than x is 12. So again, we have 3 more than x. That means you are going to write first x, then you add 3. Is represented by equal sign, and you have 12. So this is 3 more than x is 12, or x plus 3 is equal to 12. So notice in here, x plus 3 is equal to 12 will only be true if the left member will give us a value of 12. So we call this statement as a conditional statement, and that the statement will only be true if x is equal to 9. Because that would give us now the statement 9 plus 3 is 12, so your 12 is equal to 12. So mathematical statement, by the way, is true if when you simplify your left member and your right member, they must be equal. The statement absolute value of any number is greater than or equal to 0. So we use the symbol two parallel lines for absolute value of any number. So we have here the absolute value. This is the symbol for the absolute value of any number. You can represent any letter to represent the number in here. So we have here the absolute value of any number is greater than or equal. So this is the symbol for greater than or equal to 0. So we know that the absolute value of any number is always greater than 0 or 0. And so we say the statement is true. Okay, so we end up our discussion in here for translating mathematical statements into mathematical expressions or symbols. So I hope you will be ready to answer the exercises following this lesson. Thank you.